Okay, so now let's talk about the biconditional. Given statement, variables p and q, the biconditional of p and q is p if and only if q. And this is denoted by p and then an arrow with two sides leading to q. P if and only if q is true if both p and q have the same truth values, and is false if p and q have opposite truth values. So, P if and only if q means if p, then q, but it also means if q, then p. The words if and only if are sometimes abbreviated as if with two f's. Okay, so number 32 says, this quadratic equation has two distinct real roots. If and only if its discriminant is greater than 0. So they ask us to rewrite the statement as a conjunction of two if-then statements. So P if and only if Q means two things. It means P implies Q, so if P then Q, but it also means Q implies P, so Q, if Q then P. So in this case, P would equal, this quadratic equation has two distinct real roots, and Q is, its discriminant is greater than 0, it's being the quadratic equation. Now, I got P and Q from the sentence right here. P was the first part of the if and only if, and Q was the second part of the if and only if. Now, they're asking us to rewrite this sentence as a conjunction of two if-then statements. So we have P, we have Q, so all we need now is to write P if P then Q, and if Q then P. So if this quadratic equation has two distinct real roots, if P, then Q, its discriminant, is greater than 0. And how you can make the conjunction is you can just do a semicolon and then write the word and then comma, and then you can say the second if-then statement, which is if Q then P. So if its discriminant is greater than 0, I'm going to replace its with quadratic equations, so the sentence, or that if-then sentence, would make more sense. So if this quadratic equation has a discriminant greater than 0, then P. So then this quadratic equation has two distinct real roots. And there we have it. This sentence right here, its meaning is the same as this if and only if sentence up here.